Hello everyone, welcome to ExamRat. My name is Shatabdi, I'm a medical student. Okay, so today we're going to be discussing some questions on the chapter Work, Energy and Power. In case you've missed our previous sessions, you can easily just go on YouTube and check out our channel and all the previous discussions. And not only of physics, we also have videos on chemistry and biology. Okay, so let's get started. The first question is very simple, and we have discussed it as examples when we had talked about work and how do we consider work to be negative, positive, or even zero. So this is a sum based on those concepts. So it says that a force F is acting on an object of mass m. So the direction of displacement is from west. This is technically west, and this is sorry. Yeah, west and east. Okay, so yeah, observe the diagrams carefully and state whether the work done by the force is negative, positive, or zero. Okay, so let's take case A, B, and C. Here all of their masses will be m, and the blue arrows here signify the F or the force. Okay, sorry. Here is the force for the second case, and this is the third case. Okay, so let's go one by one. In case A, we are seeing that the force is upwards and the displacement is forwards. Okay, so if we somehow just by an imaginary line extend them both backwards, then we get an angle of 90 degree. So now the formula of work was Fs cos theta, right? So now what will it be? It will be F into S into cos 90, which is 0. So here the work done will be 0. Okay. Okay, next case. Here the force as well as the displacement both are in the same direction forwards. So here the angle between them, even if we extend it, so this angle is basically 0 degree, right? Because it is technically a straight line and both are in the same direction. So if we had drawn it like this, it would have been basically force into displacement. So in this case, work equals to Fs cos theta, which is equals to Fs into cos 0, which is, and you know that the value of cos 0 is 1, so Fs. So work done here is positive. Okay. The third case says here that the force and the displacement are in opposite directions, right? Now look at it carefully. If I again draw it, if I again extend these lines, then it will basically be like this. And you know that the angle here we're talking about is 180 degree, right? So here W equals to Fs cos theta, which is equals to Fs cos 180, and you know cos 180 is minus 1, so it will be minus Fs. So here work done is negative. So we get that in the first case work done is 0, in the second case work done is positive, and in the third case work done is negative. Very simple. Okay. So here find the energy in kilowatt hour consumed in 10 hours by 4 devices of power 500 watt each. So now in the previous discussion we had talked about the fact that kilowatt hour is basically the commercial unit of energy. Okay. So it's better if we calculate everything in this terms whenever, especially when we are calculating the power for devices, because the rate or the money that we have to give to the electrical companies per month is becomes easier if we calculate in the terms of kilowatt hour. Okay, so what was it basically? It was a unit which we had found out by using this formula where we had said that power into time equals to work done or energy. So here the energy consumed or the work done, whatever you feel comfortable in. So here it's basically what will happen, kilowatt. Okay, so we have 500 watt with us and we have to basically convert it into kilowatt. So what do? We obviously divide it by 1000, right? Because 1 kilowatt is equals to 1000 watt. Okay, and so we multiply this by 10 hours, simple. So this will be 0.5 into 10 or 5 kilowatt hour. And since there are 4 devices here, we obviously have to multiply this by 4. So 20 kilowatt hour, very simple. Okay. In the next question, it's given to calculate the work required to be done to stop a car of 1500 kg moving at a velocity of 60 km per hour. Okay. So I had when we had discussed about kinetic energy and work, and we had formulated an equation. What we had said was basically that the amount of work that is done to change the velocity of an object is basically the work done to change its kinetic energy, right? So here it's basically that we have to stop a car. So if we have to stop a car, then obviously what will be its final velocity? Its final velocity will be 0, right? So here we can directly write it as 0, or work done equals to basically the amount of energy that was required to stop this car, like the amount of kinetic energy that got converted into potential energy the minute the work was done. Okay, so here it's simple. We can just do it as half mv square. Mass here is 1500. Okay, now we have to basically convert 60 km per hour into meter per second. So how do we do that? We just simply multiply 60 into 5 by 18. So this is we just for now keep it as 50 by 3. Okay. So now we just okay. So the amount is coming to 12,500 joule, or we can write it as 12.5 into 10 to the power 3 joule. Simple. So here the two things that we have to keep in mind is that one, we have to like change this unit. We cannot keep it in kilometer per hour. So we do it by multiplying 5 by 18. If it was a case that the velocity was given in meters per second and we had to find kilometer per hour, then we multiply the reciprocal of 5 by 18, which is 18 by 5, to that velocity. Okay, so this is a short trick. This you can remember every time you calculate the velocities. Okay, another thing that we have to remember is that the work done to stop the car is basically the equivalent to the amount of kinetic energy that the car had possessed before it came to a stop. Okay. So, yeah, this is a conceptual question, that what is the work done by the force of gravity on a satellite moving around the Earth? Okay. So, for example, let's draw an arbitrary Earth and let's draw a satellite which is moving in an sort of an elliptical path. Okay. So when we had discussed about gravitation, we had discussed how every every object in the center is attracting every other object at its periphery, right? And that force is called centripetal force. So here also the same thing will happen, that the Earth is attracting the satellite through its centripetal force acting between its two centers. Even if it does not look properly centered in the diagram, it is actually the center. Okay, and so this is the force, this is the direction of the force that you can say. Okay, and what is the displacement exactly? The displacement at every position will be something of this sort, right? Yeah, so what you can gather from here is that there's always the angle formed between the force and the displacement at every position on the elliptical path is 90 degree. Even if it does not look so in the diagram, but trust me, it is, because the displacement is sort of a tangential path. Basically, how do we know that it is a tangential path? Is because the moment we stop giving the force, the particle will flow out of this elliptical path at a tangent to its original path. So that is how we realize that the displacement occurs in the tangent of the elliptical orbit. So here we can see that at every point it is the angle between the force and the displacement is 90 degree. So again, by that logic, so again by that logic, Fs cos theta, so we get Fs cos 90, which is again equals to 0. So even though the satellite is moving around the Earth, and even though there's a force acting from its middle towards the satellite, even though there's a displacement also, but technically in terms of physics there is no work done. Okay, so you'll get questions like this, you'll give reasons like this, so make sure that you highlight why even though there is force and displacement, that the total magnitude is coming, the product of them is coming to 0 because of this cos component and because that the angle is 90 degree. So the next question here is, see, the calculation is simple here, but what I need you to understand is that sometimes while giving an exam, people get confused and they don't exactly read the question properly. So here it is written that the certain household has consumed 250 units of energy during a month. Now when they are saying this, we have to again go back to the fact that when it is written household and they are saying 250 units of energy, it means that this means the commercial unit of energy, right? So this basically again brings us to kilowatt hour. So basically what they are trying to say is they have consumed 250 kilowatt hour in 30 days, right? So how much energy is in joules? So now we have to calculate this whole thing in joules. Now how do we do that? Very simple. (250) into 30, right? So that will come to, we have to basically convert this days into seconds, right? So what are we going to do? 30 into, first let's just say one day has 24 hours, every hour has 60 minutes, and every minute has 60 seconds. So basically what will come after this is that it's sort of a big calculation, and that is why they give you, because it's a little time consuming as well. So it will basically come to, yeah, so it will come to 90 lakh joules. So yeah, and we can also write it as, so I had done this calculation before only, so it's gonna take like a little bit of 3 to 4 minutes, but what they want you to basically is, their purpose is to make you go wrong with the sum, and so that's why they've included so many calculations and everything. But you have to just be clear that whenever they use the term household and that 250 units of energy has been spent, so they are referring to kilowatt hour. Okay. So yeah, in this case, it's written that a certain force acting on a 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. Calculate the work done by the force. A while back we had, I think it was the first sum where we had discussed about the kinetic energy had fully changed to zero, like the velocity had changed to zero, so the total amount of kinetic energy had changed to work done. So here also we'll use the same formula, which is the change in the velocity, which is a change in the kinetic energy, is brought about by the work done by the force. So we can write it as half m vf square minus vi square, which is half into mass is 20 into final velocity, change in velocity from, so 2 meter per second is the final velocity, which is 4, 2 square, which is equal to 4, minus 5 square, which is 25. So this is basically coming to minus 210 joule, right? So why is it negative work done? Because you are slowing down the subject. So that is why it's negative work done. But when you talk about the magnitude of work done, then you can say 210 joule. So that will be all for today. Thank you for listening, and we'll come back the next day discussing about the chapter sound. Thank you.